Today we're going to learn about load resistors and what load resistors are. So everyone just chill out on the questions for 5 minutes and let's learn about load resistors today, because this is something that like you guys and not just you guys, everybody has a really hard time with. It's a really confusing topic. So let's jump over to the left. Look at that. Look at that, man. It's neat.
I like it.
Right?
Like it, yeah.
Isn't that cool? All right, here we go.
Looks like we going to a party.
What is a resistor? A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines, among other things. So what we're talking about here is a resistor can do multiple fun things for us in car audio, not just what we're going to use them for. But we want load resistors. Why you need a load resistor? There's going to be a little bit of history involved in this so that you guys can kind of get a better understanding of what and why we're in the predicament we are right now. So, old AB class IC power amps were always on. They turned on. They never had an issue. If you didn't put a load on them, it didn't care, it just turned on. When no load was connected, they would still put out sound. They would usually perform better, cooler, and consume less power. You could connect to their output with no ill effect to the circuit or the sound. Life was good. So think of it like this. If you had a factory radio and you grabbed two speaker wires off of it and you hooked up your RCAs or your high level to low level or whatever you did, and you didn't do anything else, you never had a problem. It just worked. And because it was an AB class amp, it didn't matter if there was a load on it or not. It would just work. The reason why I become more efficient is because that load wasn't there, so it would just go to nominal amounts of power. It wouldn't have to do anything. Then we got Class D IC power amps. Oh, good Lord. Whew, here we go. All right. The first gen Class D IC amps were dumb and were not being designed all that well. The side effect of that was they would blow up or fail. The reason for this is a Class D amp needs to have a load on them for proper performance. Better Class D amps are designed for short-term use with no load. One manufacturer tests their amps for 100 hours before failure, but still it will fail. Alright, so let's put this in perspective before you ask the question. I have a Class D sub-amplifier. I want to do a I want to do, gain test with SMD1. Yeah. The amplifier should perform fine for a short period of time. It's going to require you to do that load test without having ill effect on it. If it's designed properly. However, it is not made to be played for a prolonged period of time without a load on it. It will start to not like itself and do bad things. In an automotive world, when you're talking about an IC power chip, it needs to have that load on it all the time. Now, there are ways to design the amplifiers, as I said, so that they won't have this, but they will still eventually fail. Let's keep going. Next generation Class D IC amps are smart and last longer. They have protection protocols in place to monitor resistance. So what would happen is you would take your speakers off, you'd put your RCA line level, whatever, onto it, so that high level to low level, which we've always been doing, and the resistance wouldn't be there. So the amplifiers would go crazy and the rectifiers would blow up because there was nothing, it wasn't getting the compression, think of it, the squish, the back pressure on it, it's back pressure, on it that it needs in order to stay on. So they had to come out with a better way. The side effect is they shut off if no load is detected. So these smarter amplifiers now have circuits in them that allow them to read what is happening. Most current Class D IC amplifiers test the load at startup and again sometime later. We see this if we test a speaker after the car is running. It will play but eventually turn off, and it will not reconnect, and the radio will not reconnect if there is no sound. In the Chrysler that the gentleman just asked about, the Renegade, it needs a load resistor. Chrysler was
Yeah.
one of the first companies out there to design their Class D amplifiers this way. Now, believe it or not, when you look at like your Japanese cars and the way they designed their radios, they were actually designing their radios better. And they put in the circuits needed for that Class D amplifier to not blow up as fast. Meaning it'll eventually blow up. It might be 100 hours, might be 3 years, but eventually it's just going to die because it doesn't see a load on it and it doesn't like it. But they built their amplifiers better. Here in the US, we didn't do that. We were like, screw you guys, we're going to build some crap. Going back to the original Class D amplifiers, it wasn't totally stupid in the sense that like it didn't know to shut off, but it would give you a check engine light, but not one on the dash. The only time they'd see it is if you went into the manufacturer, and then it would be like, hey, actually this was the start of the start of the smart amps was you would disconnect the speaker, it would trigger a check engine light that can only be seen when reading the car, but that would allow them to scan the car and be like, oh my gosh, you guys disconnected speaker, that's why this radio blew up, it's on you, it's not on us. Which obviously didn't work, and that's why the sound shut off, because they didn't want to tell someone they had to buy a new radio. That was kind of bad. So this is the predicament we're in right now. The modern Class D amplifier will shut off if it doesn't see a load, which is great, because that's a hint and a half for you, and it tells you that, oh my gosh, hook this up, you're fine, you'll be rocking and rolling. Future generation Class D IC amps will be super smart, like man give me a break smart. The side effect, car manufacturers do not want to replace or repair any part of their car ever. Ever. They do not want to fix anything for you. They have circuits designed to monitor the whole movement of the speaker, to adjust the sound being played outside of its parameters, to take a speaker's age into account and adjust it for output to limit performance. Scary stuff. So think of it this way. If you're trying to play a sound like bass roll-off, okay? So bass roll-off is basically just a generic loudness that they put in there and it rolls it off. But what if the amplifier was smart enough to go, oh no, this speaker is giving me enough feedback that I need to automatically DEQ that speaker to prevent it from destroying itself. Or you destroying it, I should say. Mm-hmm. Not only that, they can also take nominal readings of the ohm load and check out the performance of the driver. As it gets older, they can constantly adjust the wattage output to that speaker so that it has a longer life and will continue to perform without ever blowing. As you can see, the side effects to this would be tragic in the sense that there's no way to bypass this that the engineer that I talked to knew of. They were like, hey man, end game at that point. So, solutions. As for now, add a load resistor. It will provide the amp with the stability it needs to not fail. Seems pretty simple. It will trigger the smart amp to wake up and not go to sleep. It will control the high frequency distortion, usually in the 500 hertz range. One of the side effects of not having load resistor is that amplifier becoming unstable, and it really is noticed in the high frequencies. Some Class D amplifiers, when they become unstable, you blow your tweeters, and you can't figure out why you keep blowing tweeters. It's because you don't have a load resistor on it. Basically, make the IC power amp happy. Side effects and myths. Load resistors get hot. Mount them in a safe place, clear of other things. This is 100% true. These things are hot. They do not put them behind a radio where the wiring harness is. Mount them someplace where there is a pocket of air around it and nothing is touching them. They will not fix or help noise floor. This is an important thing. A lot of people think that load resistors somehow affect the noise floor in the car because of that 5,000 hertz distortion. Has nothing to do with one another. The reason why you're getting that floor noise issue is because your factory system was never designed to put out the amount of signal it's needed to play it at the wattage you're playing it at. So for example, if you have a factory system that only put out 18 watts, the signal to noise ratio on it is pretty crappy because it knows you're never going to get it loud enough to where that noise is going to be audible. So if you have crappy signal to noise ratio and then you multiply it by 100%, getting it up to 180 watts, you've just multiplied your floor noise up to 100%. You're going to get floor noise. For those who don't know what floor noise is, we'll probably do a show on that, but it's when you hear the shh sound coming from your tweeters. Okay? It's just there because it's a factory system. There's only so far we can go. They have no effect on ANC. ANC is automatic noise canceling. Don't need a load resistor to fix that. You just need to fix it. Load resistor isn't going to help that. There is no basic way to see if your amplifier is Class D. Small heatsink is the best clue. These are for Class D amplifiers only. AB amplifiers are fine, just like we said at the beginning. You don't need any of that for an AB class amplifier. You need it specifically for a Class D. Unfortunately, without getting deep into it with an oscilloscope and looking for specific things, there's no real way to test it. The easiest, pretty much every car that's been built since 2016 is using a Class D amplifier. The other thing too is don't worry if you have a Class AB and you're just trying to be cautious and put the load resistors on it. It's not going to affect your Class AB amplifier at all. It's not going to hurt it. So when in doubt, add the load resistor. Not all amps need the same load. And that's one of those gray areas. Here's examples of load resistors. The most common ones that we use, or the two that we stock, I should say, are all the AC LGDs, which you have the AC LGD blue. These are real popular for Fords and or cars that don't have the turn-off circuit. This will work fine. The new Chevys, however, all need the greens. And then the amplified Chryslers work off of the gray. Kicker said, you know what? We're just going to make one load resistor to rule them all. I like to refer to it as the load resistor grenade. It comes in a small heatsink about the size of their little bike amplifiers, and it is a low enough impedance that it will turn on any scenario you could possibly throw at it. So if you have a situation where it's cutting off or it's not working the way you want, get one of the KISS loads, throw it in there. Nice thing too is it's got a big heatsink, so you can mount it like an amplifier and everything is hunky-dory. Now the other two that we have there in the top right hand corner is your standard sandstone style resistor, and that is what is inside of the AC LGDs. And then the orange one there is the load resistor you would use for your headlights with the heatsink around it. They're basically the same, just one has a heatsink.
Also, Addison, of course, make theirs too.
Yes.
The USS4, so...
Correct.
Yeah.
I thought about that after I was done. I apologize, Lance.